So let's go through these first 12 very quickly. We've already done some of these. And the goal is to try to simplify. So cosecant times tangent. I know cosecant is 1 over sine, and tangent is sine over cosine. Those two tangents cancel out, leaving me with 1 over cosine, and that's the same thing as secant theta. So number 1 simplifies the secant. On the second one, I automatically recognize that sine and cosecant are reciprocals of each other. So when you multiply reciprocals, you always get 1. And 1 minus cosine squared, well, that's taken from that. Cosine squared plus sine squared equals 1. If I subtract cosine squared on both sides, I end up getting sine squared. So that is number 7 simplified. On the right, I've got cotangent and cosine. They very likely, something cancels out there, I'm sure, because cotangent is cosine over sine. And nothing cancels out. But I have cosine times cosine, and that is cosine squared. So I've got sine of theta over 1 plus cosine squared theta over sine. And now I've got two fractions. I can always combine those fractions. I get a common denominator. So I have to just multiply this by sine over sine. So that left fraction becomes sine squared over sine. And then I've got plus cosine squared over sine. That's sine squared plus cosine squared over sine, which is 1 over sine, which is cosecant. So number 2 would boil down to just cosecant. And I need some space, so I have to erase all that. Number 8, I can't factor anything out. I know secant is 1 over cosine. I've got the sine. I can change tangent to sine over cosine. And this works out a little bit more nicely. I've got 1 over cosine, because I have the same denominator, minus sine squared over cosine. Well, they combine to 1 minus sine squared over cosine. But 1 minus sine squared is the same thing as cosine squared. And the two cosines cancel out, leaving you with just cosine of theta for number 8. Cosine of theta for number 8. Number 3, I recognize that cosecant squared is the same thing as 1 plus cotangent. So I can replace this with 1 plus cotangent squared, and cotangent squared minus cotangent squared, they cancel out. So that just leaves me with number 1. 3 just equals 1. This one for number 9, I have 2 things I can just double distribute. So cosecant times cosecant is cosecant squared. Cosecant times minus 1, and then 1 times cosecant, well, those 2 cancel out. So the 2 middle terms cancel out. Please realize that these 2 things are conjugates. So when you multiply conjugates, you end up getting the difference of squares. And here are the difference of squares that I'm getting. I'm getting cosecant squared minus 1 squared. Well, remember, cosecant squared equals 1 plus cotangent squared. So I can replace this with 1 plus cotangent squared, and then that minus 1. Well, the 1 and the minus 1 cancel out, and I'm left with cotangent squared for number 9. Number 4, I automatically see that those secant squareds, there's 1 in each term, so I can cancel those out. Factor that out. And I'm left with 1 minus cosine squared. That's just like number 7. 1 minus cosine squared is the same thing as sine squared. So secant squared times sine squared. Do you see what that is? You see that that's tangent squared? Secant is the same thing as 1 over cosine. And this ends up being sine squared over cosine squared. And that is tangent squared. So for number 4, tangent squared. I'll get back to number 10 in just a second. Number 5, I got sine squared plus cosine squared. That's automatically 1. 1 plus tangent squared. Well, we all know that that equals just secant squared. So that's number 5. Number 6, 1 plus tangent squared is secant squared. And secant is 1 over cosine. So this is really cosine times 1 over cosine squared. Well, only one of those cosines cancels out. So I'm left with 1 over cosine, which just equals secant. So for number 6, it is secant. Number 12, sine squared plus cosine squared is 1. So I've got tangent squared theta minus secant squared theta times 1. Well, secant squared is 1 plus tangent. So I can rewrite this as tangent squared minus, I'm replacing secant squared with 2 things. So I have to group those 2 things together. 1 plus tangent squared. And then if I distribute that -1, I get tangent squared minus 1 minus tangent squared. The 2 tangent squareds cancel out. And so all I'm left with is -1. Number 11, I don't have any squares, so unfortunately I can't use that right now. Let me just multiply, let me just distribute out. So I got cosecant times 1, cosecant times cosine, cotangent times 1, cotangent times cosecant. Ugh. Nothing canceled out. It's unclear what to do, so I'm going to change everything to sines and cosines. So cosecant is 1 over sine. Cosecant is 1 over sine. And then cosine. Cotangent is cosine over sine. Cotangent is cosine over sine. And cosecant, oh, sorry, cotangent times cosine. I miswrote that. So this is actually, this looks like it's good news. I mean, it's encouraging to see that you've got, there's a bunch of fractions there, but all those fractions have the same denominator. Okay, so continuing on, I got 1 over sine minus cosine over sine plus cosine over sine. Oh, those 2 cancel out. That's nice. Minus cosine squared over sine. So those 2 fractions become 1 minus cosine squared over sine. 1 minus cosine squared is the same thing as sine squared. One of those sines cancels out, leaving with 1 left over. So that is number 11. And then lastly, number 10. I've got sine over, there's more than one way to do these. So I know I've got sine over cosine times 1 over tangent. That's true. I mean, because if you're ever in doubt, just go backwards. If you start off with this, if I were to multiply those 2 fractions, do you get that black fraction? And the answer is yes. When you multiply fractions, you just multiply top by top and bottom by bottom. Well, sine over cosine is tangent. And so what am I doing? I'm taking tangent times 1 over tangent. So I'm multiplying 2 reciprocals. So the whole thing would just equal 1.